Okay, we're going to go a bit further beyond polynomial division. We're going to look at what's called the Remainder Theorem and also the Factor Theorem. And I'm going to keep the explanation simple, and I'll stick to some simple examples. Those are as simple as possible. Because this topic could go further, but we'll keep it quite simple. So if we can consider p of x a polynomial equals x cubed minus x squared plus 2x minus 3, what if we divide that there by this divisor, that divisor there, x minus 2. So of course if you're watching this video, it's important that you've done polynomial division before. So here we go. So to get the x to match with the x cubed like that, we have to multiply x by x squared. So positive x squared goes up there, and minus 2 times x squared is minus 2x squared, and we have 0 in the other places. So we subtract, and we have negative x minus negative 2, so that's plus 2, so it gives us x squared there, and we bring down the other terms. So we need an x squared there, so we need to multiply by x, so it's minus 2x there. We have 2 minus negative 2, which is 4x, and minus 3 comes down there. So to get the x to match with the 4x, we need to multiply by 4 up the top in the quotient, and negative 2 times 4 is negative 8 or minus 8. So we have the 4x's cancel out, and we have negative 3 take away negative 8, negative 3 plus 8. That's a remainder of 5. Okay, we have a remainder of 5, and we have a quotient of x squared plus x plus 4. Okay, so what we did was, starting with the polynomial x cubed minus x squared plus 2x minus 3, we said that's equal to x minus 2, the divisor, times x squared plus x plus 4, the quotient, plus a remainder of 5. So note, the remainder is 5 when x minus 2 is the divisor. Now, what if we just did this? If we found p of 2. So in other words, p of 2 is when we substitute 2 into the polynomial. Now I could sub it into the left or the right, they are equal. I'm going to sub it into the right. Okay, so p of 2, wherever I see an x, I'm going to put in a 2 in this case, because remember the polynomial itself is called p of x, that's its name, p for polynomial. I'm going to find the particular case p of 2, and I'm going to sub 2 into the right hand side wherever I see x. 2 take 2 times 2 squared plus 2 plus 4 plus 5. Now straight away, the whole right hand side, that there is 0. 0 times anything is 0. So we have all of this here, all of that, that's two things multiplied together, it's a product. Of course the first part is 0, the whole thing's 0, it's null. So that's 0, and we have a plus 5 still on the end, so 0 plus 5, so it's 5. Note that the remainder was 5 too. Now we can generalize this into a very useful rule called the Remainder Theorem. Okay, so in general, if we've got some polynomial, just like that one there, alright, p of x, and that p of x, after you've done division, can be written as a factor, x minus, that little symbol is alpha, which is a Greek symbol, it just means some number, so we'll call that some integer number, some whole number, positive or negative value. Alright, so x minus some integer times q of x, which is the quotient, plus r, the remainder. Now you need to remember from previous work, previous videos, what the meaning of remainder, quotient, and divisor means. So the x minus alpha is divisor, q is the quotient, and r is the remainder. Okay, and we've basically got those up here. So that's equivalent to that in that particular case up there. That's the quotient that we got just before at the start of the video, and of course that one on the end of 5 is the remainder. Okay, so we can use that as the remainder theorem. To find the remainder, if we go p of alpha, so whatever the integer alpha is, whatever the number alpha is, if we sub it in for x, we have alpha minus alpha times q of x, or q of alpha actually. So that's, we sub the alpha into everything. Wherever there was an x, that number alpha will get subbed in. It's just an integer, alright, plus r. Now of course, like we saw just up here, that will come out as 0. 0 times anything. Doesn't matter what q of alpha is, it doesn't matter at all, you just get r. So 0 plus r is r. So that's essentially the remainder theorem. Okay, so that's the remainder theorem. So remainder theorem, briefly written, when we have p of x divided by x minus alpha, the remainder is the same as just going p of alpha. Okay, so that's your remainder theorem right there. So let's look at a couple more examples on top of what we've seen. So because we've seen that in this case here alpha equals 2, it's x minus alpha. Alright, so alpha equals the 2, and then we've got a remainder of 5, which is easy to see there. Alright, we saw it in the division above as well. See? In the blue. So the remainder was 5, and when we went p of alpha, because alpha is 2, we also get 5. So it's a quick way of determining what the remainder is. Now that has a point. We'll get to that in a minute. So a couple of quick partial examples there. When dividing a polynomial by x minus 3, the remainder for that polynomial is the same as p of 3. When dividing by another example down here, dividing by x plus 2, now that's not in the form x minus alpha unless we go x minus negative 2. So therefore the remainder will be the same. The remainder will be the same as p of negative 2. So when you've got a plus situation, it's p of a negative number. And I spelled remainder wrong there, I missed an n. Okay. So what if the remainder is 0? Okay, if the remainder is 0, we have perfect factors. And that brings us on to a similar idea called the factor theorem. So when we've got our old friend polynomial p of x, and it's divided by x minus alpha again, where alpha is an integer, and the remainder equals 0, following the remainder theorem, p of alpha equals 0, and that means thus x minus alpha is a factor. It's a perfect factor. There's no remainder, so when there's no remainder, it's a perfect factor. It's a factor. So examples of that, if we've got x cubed minus 3x squared minus 3x plus 10. We can just use polynomial division like we started the video at. You could try it yourself. You'd if you divided by this, if you divided p of x by x minus 2, you'd get a quotient of, on the top of the division setting out, you know, right at the top, you get x squared minus x minus 5 if you did the division yourself, and there'd be remainder would be 0. There'd be no remainder. Okay, you could try it yourself. So in other words, try this process that we did at the start. So you'd get the remainder would be 0 in that one we're working on now. Okay, you could easily pause the video and try that yourself for a bit of practice. But using the factor theorem, right, the x minus alpha where alpha is 2, we can use the remainder theorem, or in other words the factor theorem, because we can show that it's a factor. It's basically just using the remainder theorem. We can show quickly that, or we can get a factor quickly by going p of 2, subbing it into the right hand side of the equal sign, so that it'd be 2 minus 2 times 2 squared minus 2 minus 5. Now we don't even need to calculate that because 2 minus 2 is 0. So p of 2 is 0. So if we have a couple of quick examples to finish the video off. So what it's really used for is finding factors of polynomials. Now that polynomial, if we had to find one factor, and we're going to be calling these later on linear factors, to find a factor or a linear factor, because these are all linear, aren't they? It's x to the power 1. Okay, so to find a factor, we use the factor theorem, which is just a version of the remainder theorem. Okay, so alpha in this one is -1, and so we need to find p of -1 in this polynomial here, and that's -1 cubed plus -1 squared minus 3 by -1. I'm going to run out of room, and minus 6. So that's -1 plus 1 plus 3 minus 6, and that's 0 plus 3 minus 6. That does not equal 0, does it? Okay, that's equal to -3, so therefore not a factor. Lastly, how about x minus 2? Okay, first thing, what's alpha? It's x minus alpha. Alpha is 2. So we look at p of 2. P of 2 is 2 cubed plus 2 squared minus 3 by 2 minus 6. Okay, which is 8 plus 4 minus 6 minus 6, which is 12 minus 12, which is 0. Yes, so the remainder is 0. Remainder equals 0, therefore this is a factor. That's a happy way to finish the video. We found a factor. Yay.